Hello students, welcome back. In this session we are going to discuss about isometric projections of a descriptional figures. Means suppose these are the figures, this would be given in the question format, but these type of figures will be given in a descriptive manner. Suppose there is a cylinder and above the cylinder there is a cube and above the cube there is a triangle. So the length and the dimensions would be given for those cylinders, cube and pyramids placed one over another, and we have to draw the isometric projections of that figures. That's called descriptional figures. These are called given figures. I'll show you one more thing. These are isometric projections for the given questions. Here, this is the question and this is the answer. This is iso and this is orthographic. So for these type of questions, there is no description for this. Directly question will be given and you have to draw answer according to this one. But some figures will be having a description for that and we have to draw accordingly. For this description figure, I am considering a cylinder, a cube and a square pyramid one over another in vertical position. Right, I have made a three-dimensional model for these question. This is one. This is the bottom one is a cylinder. This is cylinder and this is a cube and this is a square pyramid. Looking from top you can see the square pyramid, a cylinder shape, right? Now the cylinder diameter is 60, height is 30, cube side is 40, so the height is also 40. Next, the side of the pyramid is 30 and height is also 30. So let's draw the two-dimensional structure of this figure first, then we will go for the three-dimensional. Means first I have to draw the isometric orthographic projection of this objects, combined object placed one over another onto the sheet, then I can go for isometric projection of this one. So the top view of this figure would be a circle, a square and a square with triangles, right? And this would be the front view, rectangle, square and a triangle, right? So let's draw this first. For this I'll be drawing the orthographic view first, this one. So it would be easy if I start with the top view, then I can go for the front view. I'll be drawing the circle, first cylinder, top view. Next I'll be drawing the top view of the cube. Here the diameter of the circle is 60. The dimensions of the cube is 40. Right? So I have drawn a cylinder top view, square top view. Next I'll be drawing the top view of the pyramid. The dimensions of that is 30. We'll be having face edges. Let's give the dimensions for this. This is a square pyramid, 30. This is cube, 40. And this is cylinder diameter, 60. Right, now I have to project this for the front view. This is the top view. This is the axis. This is for a cube. And this is for a square pyramid. The height of the cylinder is 30. If I take 30 for this cylinder, the figure would be coming above this one. So for that I'll reduce the dimension of this one to some 15. Okay. Or else 20. I'll reduce that to 20. Next cube. Next I have to draw the pyramid. I'll erase this. So from here I'll take 30 height, the altitude of the pyramid. I have corners, this corner and this corner, and the apex point. Right? So there is a cylinder, cube, and a square pyramid over here. The height this is 20. This is 40. And this is 30. So for the isometric of these type of descriptional figure, it is compulsory that we have to draw the orthographic first, then we have to go for isometric. So this is the top view and this is the front view. And for these type of figures, it would be easy that if we keep one of the structure, that may be front or top, in a box, so we can directly create that box in isometric very easily. So I'll be placing this in a box and this in a box. So I have placed it in a box. A, B, C, D. Now I'll take this has length, this has width, and this has height. So I can place whatever the lines coming parallel to this one, 1, 2, 3, 4, 5, 6, all this one are in length. Whatever the line parallel to this one, width, that I place will be width. And coming to these lines in front view, I'll take on height axis. Okay. Now coming for the isometric, I have to draw the three lines. What are they? Simply length, height and width. And they are equal to 120 degrees to each other. 120, 120 and 120 degrees. So I'll be placing these type of lines over here. So this is 0 line, 30 degrees, 30 degrees. If I draw these two lines and a vertical line, I can place length, width and height on these things. This is length. This is width. And height. This is height. So this is length axis, width axis and height axis. So now I have to place this over here. So already have placed this top view in a box, and coming to top view we'll be covering with length and width. So I can place all the length lines are parallel to this length axis, and all the width lines parallel to this width axis, and all the height lines parallel to this height axis. So I'll be placing this box over here. I'll be taking this as the origin. From here I'll be taking width, here length. So I'll be placing this 0 at this position and at this position, right? So whatever the lines coming from this origin would be start from this point and this point. So this box is of dimension 60, right? So simply I can take a compass. I'll be measuring this dimension 60, from here 60, from here 60, from here 60 and from here 60, right? So already we have some points over there. This point would be B. These are projections and this is true shape. So I'll be taking capital letters over here, B. Next, this point would be A. This point would be D, and this point would be C. See here, this is width BC, BC is a width, AB is a line, AB is a line length, right? And again, AD is a width. See here, width. And DC is a length. DC is a length, right? Now close this. Now see here, this ABCD box is placed over here. And we have an intersection of this cylinder, circle, at this point, this point, this point, and this point, right? So we can construct the circle here, right? So we have this intersections. So for constructing any of the object here, we have a box, right? So do we remember the method how to construct a ellipse in rhombus method, or else four centric method? Four centric, 1 2 3 4, right? So this is a rhombus. We have midpoints, right, resembling the same, and we have to join this line to this, here, here, and here. You will be getting intersections over there, right? These are the focus points. From here, measure this distance and draw arc, keeping F1 as center. Now this has center, measure this distance, arc. Next, this has center, measure this arc. Next, keeping this as center, measure this arc. So you have constructed ellipse in this rhombus. So see here, this ABCD rhombus is a resemblance of this, right? Then this ellipse would be the resemblance of this circle. So here we can construct the circle here by using this method. So already we got the midpoints. We have to join the lines to the opposite corners. So we got focus points over here. Now measure that. We have drawn an circle in isometric structure. This is focus 1, focus 2, and this is vertex 1, vertex 2. From this I can draw a cylinder. At what height? That I have to take 20, right? From this point I can construct (20), or else you can create a same box above, because this is the top view, means I can get the view over here, I can get the view over here. Or else simply by reproducing the same technique above, you can construct the same top view of a cylinder. (16) So here we got a cylinder in isometric structure. Now coming to all these lines, these are hidden. This is dark. And coming to this, I'll draw the cube, then I'll draw the hidden lines for that. So where is the cube? That is placed right over the cylinder. So we have to find the center point of the cylinder. Then we have to create the same box here. Right, so I've created the same box above, and the square is in that box, so I can measure that. I'm measuring this. I can't take like this. I can place this square right in this by drawing parallel lines, length lines. From here to here it is 10 mm. See this? 10 mm, 10 mm, 10 mm, 10 mm. Ten, 10. And here also 10, 10. Right? From this I have to take the height, that is 40. from this point. This would be hidden. Body. $40. This would be 40. Sorry, I have drawn this dark, but this would be in a hidden form. So I've got a box for this and remained with this one. Dark, dark, and hidden. And coming to the square cube back end, this also would be hidden. Right? Next I have to place the square pyramid onto this, right? For getting the square pyramid, I have to find the center of the object, because from the center only I have to draw this apex point. 42, 42. From here the height is 30. This is the final apex point. For this I have to join that, and here the top sides of the pyramid is 30. So this is 40. I have to take 5 mm, 5 mm, 5 and 5. So these are the edges. Now I have to join to this apex point. And these are hidden. For the cube, and this is a hidden for square pyramid. So in this way we will draw the isometric position of a description figure. see this figure is reproduced over here. So for better clarity, I'll draw all these outer edges, visible edges with the blue sketch. And hidden lines. Construct the isometric structure of this combined figure. This is a cylinder. Top view is a circle, front view is a rectangle, and this is a cube. Top view is a square, front view is a square, and this is a square pyramid. This is the front view, this is the top view. Here, the square pyramid, cube, and a cylinder in isometric structure. I hope everyone understand this, how to construct the descriptional figures isometric projections. First we have to draw the orthographic, then we have to follow the isometric. So here no need of representing the dimensions for these type of figures, because already the dimensions are present here. That is our drawn, so no need of drawing the dimensions for these type of isometric, or orthographic dimensions would be sufficient for this. And thanks for watching this, and do subscribe the channel and follow it regularly for updates in engineering drawing. Thank you.